Hi, my name is Veen. I'm from the Mobile System Design newsletter and book. And today I wanted to show you how to run Rust as a multi-platform solution. And specifically for today, I want to focus on iOS. So there are a couple of things I want to talk about. So the first thing is just why. Like companies are using React Native, Kotlin multi-platform, other solutions. So why am I picking Rust as a viable alternative? And then the process will be how we're going to build a Rust library and then go over how to make it all work in iOS. And for that, we'll use Mozilla's UniFFI, and I'll talk about that in a second. And then we have a sort of like rudimentary, simple version to get it to work, but it has a couple problems. This is kind of also the issue is where, guides kind of stop. Right? They show you like, look, this is how you compile it and drag it in your Xcode project and it just works. But I want to talk about the problems and then come with the solution, which will be the shape of a Swift package. It'll be quite a nice workflow. You update Rust, run the script, and you can just pretend it's Swift code and just be none the wiser if you want to. And yeah, that's kind of the benefit of this build script I'm making here as well, because it will do all the steps and take all the hard parts out there. So, but first the question is like, why would we want Rust? So what I think is interesting is nowadays the world is more like businesses, are more like focused on React Native and Kotlin multi-platform. And yeah, it's easier to write things to AI like Claude Code. I use Claude Code myself a lot. I like it a lot. But my theory is, like, if AI makes it so much easier to write code, then why don't we focus on the low-level code? Like for example, if there's no AI, I can write, for example, like React Native. Like I have JavaScript developers in my team, for example, and they can just help and write TypeScript, and now we have an iOS and Android app. But with AI, this is easier. But my theory is more like, what if we go low-level, use AI there, and make it easier to make more like C-level code, like Rust or C++. In this case, I'm going to, of course, talk about Rust. Because I got to be honest, like the bar to write Rust code is quite high normally, because you need to learn about the borrow checker, which is like a sort of memory safety tool, like a compilation step that makes Rust development already quite intimidating, I would say. But with Claude Code, it's for me a lot easier to write it. So my theory then is that, okay, if I have a Rust library, and it's easier to write, I can use it on any platform. So for example, let's say you have a Flutter app, right, and it needs to perform really well. Well, you can write a Rust library. And then if your team changes their architecture, they're like, no, let's actually switch to, an iOS and Android app separately, right, for max performance and max everything. Okay, well, the Rust library still works. And then if the team changes again, they're like, no, let's actually use React Native. The Rust library still works. So it is more, I would say, a universal, more timeless technology. And if you have this library, like these libraries written in Rust, it will be easier, that's my theory, to have it survive all these like platform changes, right? Like if Kotlin multi-platform is the new thing, the Rust library still works. Swift for Android, the Rust library still keeps working. So yeah, that's kind of what I wanted to experiment with and show you. But the problem is that it is not backed, right? There's not like a real like company that makes sure Rust is like, Apple is not like Rust works on iOS and, we're the same for the Kotlin. We have Mozilla, which did some outstanding work that makes it more possible to write Rust code and have it run on iOS and Android, and that's what we're going to use. We're going to use that library called UniFFI. But yeah, I think multi-platform is still moving a lot, and AI-based programming is moving a lot in the mobile space. And what my goal here is to really show you, like, look, with Rust, you can also achieve a lot. And the hurdles are there's just not good tooling. So I wanted to show you how to do it. And we end up with a good script, so it makes it really easy to write, Rust code, get in iOS. And the goal would then be, as a next step, to also have this Rust code work on Android. If there's enough interest, I will show that too. I have to still figure that out though. But at this stage, I have a very nice workflow for iOS. Yeah, so let's just begin. Okay, so I'm gonna share my screen. Let me start with the terminal. I'm just gonna, take it one step at a time. So I just have an empty directory. So first, what you want to do, let's click the right links here. So first you want to do is, shocker, install Rust. Really gonna start from scratch. And again, at the end, you just have a build script and you just don't have to worry about all this anymore. So yeah, run this command, you have Rust installed. Then we're gonna start with a new Rust library, right? So we can run, it's like Swift package manager. Cargo is like the Swift package manager, but for Rust. So start a new library. It actually generates the directory for us, so we can go in there. Something Swift package manager doesn't do, it annoys me. Maybe there's a secret flag I can give. So if we see the files, we have a cargo toml file, which is like a package.swift, is the manifest for the dependencies, which we'll edit soon. And we have a library. So because we said we wanted a library, we don't have like a main function with the command line tool, because this is needed for Mozilla's UniFFI, which we'll use soon. Okay, so what I can recommend next is to install Visual Studio Code, or you can use another editor, just not Xcode. And then we can open the folder. Again, it's going to be very beginner-friendly guide as well, but I think it's good to be complete. So we just open the folder Switzerland. I forgot to mention, why do I call it Switzerland? Because it's neutral territory. So, it's neither Swift or Kotlin or the best. It's just a neutral library. Okay, so yes, I trust myself. Here we go. So we have the library. This is standard Rust code. Pub event. I'm sure if you're a seasoned veteran developer, you can figure out this means public, this means function, and this means it returns US64 type. It also adds some tests. Before you run, you do need to install a couple of things. So you can go to, where is it? Extensions, settings extensions, right? Command-Shift-X. Also fine to use, and you will install the Rust Analyzer. That's what I would recommend. It allows you just to build. If I want to, I can then use Cargo to build. So, anyways, we're gonna make a little neutral like greeting. Let me see if I can improve the font size a bit. Okay, so it's just a string function, very small, hello from Switzerland. We'd have to say toString, which is a Rust thing. As a Swift developer, you're like, why do I need to do this? But Rust, everything is more explicit. That is maybe more tedious to work in, but it is also more clear what's going on. Let's see, what can we do? Well, we can build, right? Command-Shift-B gives you the menu, you can build. But from the terminal, you can also say cargo build. And again, we have nothing to run. So that's kind of the problem right now, because we need a library, but we can't really run it. So what we can do is, we had that test you saw earlier, but what I want to show you is another approach, which is to make a new folder. So we go to new folder. What am I doing? Go to new folder. Here we go. Call it examples. This is a convention by Cargo, because if you put something in the examples folder, you can run some code outside of your source. So it's not packaged with the source, it's separate. So if I would then make, you have a lot of notes I'm looking at by the way, because we're going to follow a lot of steps. So if I make a new file, hello.rs, right, then we can put a main in here, and we can print something. Again, it's not as ergonomic as Swift, but it looks a little like Swift. And we use the Switzerland library to call our neutral greeting function. So now we can, for example, say cargo run, and we use the example hello, right? So it works. So we have a little library workflow, right? We can work in a library, change things, and then we don't have to do anything here, and we can just run it here. Cargo run example hello. Perfect. all works. If we then look at, let's say, the hierarchy, we can go to target, where is it, debug, and then we have examples. Hello, there's our program, right? Our compiled program. You can run it here. Same if you would run it with the release flag, which would be like an optimized build, right? It takes longer to compile, maybe not this one function, but you would have a release build, and then it will be target release examples. Hello, right? Perfectly optimized string function. Okay, this is just a little warm up, right? We're gonna keep going. So first we're gonna, so the next thing is to figure out how to get bindings generated. So I have to talk about FFI. So UniFFI from Mozilla, what it does is it takes compiled Rust code and then generates Swift bindings or Kotlin bindings or Python bindings, it can do that too, and that will use that generated Rust code. And FFI is foreign function interface. It just means that two different programming languages can talk to each other. You may already know this with, like, C bridges, where you can use C code from Swift or Rust. But what UniFFI does, it helps you really convert types. So if I have, like, let's say a struct or enum or like a function, UniFFI will then turn this into proper Swift types or real Kotlin types. So that's pretty cool. But we need to add it as a dependency. So that's what we're going to do next. And for to achieve that, we are going to edit the toml file, which is again like a package.swift. It's the manifest, right? So first one I want to add, stealing from my notes here, the type of grade. So library is just a standard Rust library, it helps you write tests and stuff. That's not needed, but I add it here for if you want to add tests. So static library, the static lib, is what we're going to compile to. So this will generate a file, which you see in a second. Yeah, this file is what we'll put in iOS. So then there's a dynamic library, and this is used by UniFFI to look at what is generated, and it will inspect, and then it will generate Swift code for us, or Kotlin code if you are a Kotlin developer. So if I were to run this now, if I do, or I can also run here, cargo build. So if I go to the folders, you can see there's now a .a file. That's because we added the static lib. We can see it's a 16.5 megabytes file. I can also maybe run a release version, which in theory should be the smallest optimized version. Again, it's, yeah, our code is basically nothing. It's one line basically, so it's not gonna make a big deal, big change. But I want to make clear that when you use this solution, you will have to, your build size will increase by 60 megabytes. That's a cost, right? The reason it's 60 megabytes is because there is the Rust standard library inside of it. And there is a way to even remove all of that too, but I'm not that advanced, to be honest. Maybe in the future I can look into that. But yeah, 60 megabytes is the cost for an empty library. So 60 megabytes plus how much code you'll write will be the total file here. So a little interruption. The total file size will be 32 in the end. I do mention it later in the video, but not right now. The reason for that is that UniFFI will also be compiled in. So just so you know, there will be like the total megabytes that will be added. Okay, let's get back to the video. Okay, so we have the library here that we added. Now we need to, let's see, what else do we need? Yeah, we need the dependency on UniFFI, I should say. So on the dependencies, we can add a new version, and we want a command line tool that will run as part of the build step. So we add that here. I think that's it for now. Okay, so I added the all this text here, and if you run cargo build, it will download everything. That's the next step. I fast forwarded a bit because it's a bit slow the first time. So what you also want to do is make sure inside the lib, I went ahead a bit, you add setup scaffolding and adding a macro to the function we want to export. So you may think like, yeah, I have a public function like right here, pub. But UniFFI really needs a way to know which functions are really exported to create bindings for. So it's not the same as a public function. So you set up this once, and then for every function you set up the export macro. Now, you may not want to sprinkle these macros around in your code base. There is another way to do it. You can create a so-called UDL file, which is UniFFI's way to figure out what to export. So this file would just say which functions and types are all exported, and then it stays out of your source code. But I think for this demo, I think this is fine. I also would recommend not to create a giant API anyway, because you want to, I think, should prefer a small API, so then a few macros are not really gonna hurt. So yeah, so we run cargo build. It's all running, it's all compiling, so that's all good. Let's see, the next step is to create a command line tool. Again, I went ahead a bit, but in the source, you have a bin file, bin folder. Inside you have a file. So this is like the examples folder where you can create a command line tool, but this time it lives inside the source folder. This is part of the project. And this allows us to run the UniFFI command. Now, the idea will be that this is part of a source, but you can also have the command just separate out of your project. That's fine too. But this way, everyone has the same source and the same version, whatever. So I think this is just a fine alternative. So now we have UniFFI as our dependency, and we have it as a command line tool ready. So we can use it now. So first, we're gonna make sure we're gonna build. Okay, just a regular build. Okay, it's all fine. Sometimes I forget this step, and then UniFFI just silently fails. So it's one of those things. Yeah, we're gonna see this a lot because we're working from the Rust platform to iOS, so we don't have like a multi-platform compiler that will be like, oh, you didn't change this in Rust properly, you didn't rename this in iOS properly. So yeah, that is kind of the price we pay, right? The complexity. So we have little things that can fail. Even a rename will fail the entire project. So that's why I'm gonna capture this all in a script soon. But for now, I'm just running the commands. So I have the regular build command, made my doc disappear. There it is again. All right, where is my mouse? There. So what I can do now is run this command. So we have a bin, right? We have the bin folder, so it detects this file. And then what it will do, it will generate based on the library. So cargo build created this for us because we remember in the TOML, we said we wanted a dynamic library as well. So if you look in the file, we have this dynamic library. So we're going to use this. And if you keep in mind, this is automatically prefixed. So if your name is, if your project name is like, I don't know, table, it will be lib table. Okay, so pick the language, Swift, iOS, and where does it go? Bindings. Let's run. Oh, it's very fast, luckily. Let's go to the folder, bindings. So we see 3 files. Okay, so this is the header file. Let's see if I can open it. Here we go. Just generated C header files. I mean, yeah, you can read it in your, if you're lonely, but you don't have to look at it too much. Then there is a Swift file. Again, I generated a lot of stuff, but what is interesting here is our code is in here. So we have in Rust, we have neutral greeting, right? It's snake cased, but in Swift, it's nicely renamed to camel case format. So this is what UniFFI does, right? It can take Rust types and make a nice little like Swift wrapper for us, or Kotlin wrapper. In fact, if you want a Kotlin version, maybe, well, let's just do it. Let's just see what happens. Bindings, Kotlin. Whoop. We will have a different file. So we get a Kotlin file. Amazing. So I don't have the Android stuff installed yet, so I'm going to just vim it. But yeah, maybe you also have, do we have neutral greeting? Oh, we have something here. Yeah, here, there it is, right? Kotlin string, there you go. So it can generate different bindings. So This is not a Kotlin tutorial, unfortunately, for the Android developers, so I'm going to delete it. Okay, so what we have now is the Rust project already using UniFFI to generate the bindings. So let me go to the next step. So the next step is we're going to compile for iOS. So you have seen I've already been building with cargo build and cargo build release, right? This uses like the local way of building, but I want to specifically build for iOS. And I also want to specifically build for the iOS simulator, which runs on a Mac, right? Like Apple Silicon or Intel. So first you need to add the targets to Rust so it knows what to do. So you have this command. And this will all be also in my newsletter, so you can still refer to it. I also have I will upload a Git project as well, so you can also look at all the source files there. So you add the iOS architecture, the ARM architecture, and the simulator, right? Well, I already have it installed, but in your case, you'll probably need to wait a bit. Then for Intel, I'm on a Apple Silicon M1 Mac. But for if you have Intel, you also want to add this framework, this architecture, I mean. I'm not going to do that. Okay, this is only one time because you just have to have the architectures installed. Now, we're going to compile. Okay, so very exciting. So we're going to build a release build, because if you want to put something on iOS, I want to put a debug build in. Like debug builds is nice for quick iteration. I mean, you're working in Rust, but like when you actually give it, to ship, you don't want to have like debug versions in there. So we add it for iOS, and we also build for the simulator. So this is going to take a while. So what I recommend meanwhile is we just going to make an Xcode project. So let's start. Gonna drag it in, create a new project. Let's make an app. I'm going to call it Matterhorn because we're in the Swiss style. Okay, let's see. I'm going to go on the workspace. There we go, Matterhorn. There it is. Okay. I want to run this on my phone. This is all going to take a while. Let me look at the compilation. Okay, so I will fast forward the video so you don't have to wait this long. Okay, so we can see everything is compiled. If you look now in the Rust project, we can see we have these two frameworks. And it's a release build. So what we want to get are these .a files, which is the static library, which is, .a stands for archive, static archive, I should say. So what we can tell now is this one is 32 megabytes, pretty much. This is because UniFFI is compiled in. The problem is that UniFFI, even if you follow their guides, it doesn't really say this. But yeah, that's kind of also the problem, right, with this multi-platform stuff. Like you follow the guides, you make it work, and then the guides are kind of sparse. There's not a lot about it. You just got to figure stuff out. Anyways, that's why I'm here. But yeah, we have the regular release, compilation stuff, the archive, and also the simulator one. And those are what we need. And also what we're going to need is this .swift file. So those are the three things we want. So first, we're going to make an XCFramework. The goal will be that the XCFramework helps Xcode pick the right architecture, right? So it picks either the simulator .a file or the iPhone or tablets .a file. For those that remember, you used to have LiPo for this, or LiPo, where you will make fed frameworks, but now we're going to have an XCFramework that helps us pick this. So the thing is though, Xcode doesn't like this name. It needs a module map. This module map tells Swift, where the header file is, but we need to rename it. Like, it has to be called module.module map. Like, again, if you don't do this and we have everything else perfectly working, Xcode will just throw these random errors. Like you can import your project, your module, the Rust library, Swift module stuff, but it will just throw these errors like cannot find Rust buffer and all these things. So again, it's multi-platform. That also means there is no real compiler or anything that helps. So we are on our own if it fails. So keep in mind, you got to rename this. Let's see, the next step will be to make the XCFramework. Okay, so we're going to go to terminal. We can run Xcode build, and we're going to add two libraries, right? The sim, and the regular one, yeah, call it Switzerland.XCFramework. See what it does. There you go. So we have the XCFramework, generates a plist for us, and we have the stuff in here. Not sure if it needs this .swift file, but I'm just gonna leave it for now. One thing that tripped me up here is if you run it again, you just put in a script, it runs, you're like, yeah, I'm gonna continue, but there's this line, like it doesn't like it when you generate it twice in a row. So what I recommend, and that's why we're gonna have a script soon, is you're gonna have to remove, remove it, right? So now you can just repeatedly run it, no problem. So these are these things that you're gonna just be mindful of. Okay, so next step, let's see. Okay, yeah, we're gonna put in iOS. Then we're already done for the simple version. Then we have a more nicer version. Okay, so what we're gonna need is the XCFramework. Shocker, I know. So we need the XCFramework. But we also need the Swift file. Okay. This Swift file is the actual Swift code that we're gonna call. Remember that neutral greeting Swift version? Well, we can call it now. So let's go to the content view. So we need to import Switzerland FFI. And yeah, that's kind of the thing. It's not capitalized. And if you look inside the module map, we can see it's not capitalized. If you rename this, it's gonna break. I don't wanna touch generated code. Let's say, even if you get it working and UniFFI updates something, you know, it's gonna break. I think they also say it. You don't wanna mess with it. It says it's very small, but it says it there. Yeah, so this is it already, and let's just replace this with the neutral. Here, there it is, neutral greeting. Oh, it's already working in the preview. Hello from Switzerland, no platform wars allowed. Okay, so cool. So it's pretty awesome, right? We have a Rust project. Okay, it doesn't do a lot, but it's working. Get this in, and it just runs on iOS. Pretty cool. So what I would do next is to create a build script, because you want to repeat this, right? You want to have a workflow. So you want to edit what stuff, you know, get in iOS. In fact, let's just edit. You know, if I want this like blah blah all out of it, let's do a different one. Platform wars are allowed. It's more fun. Okay, let me pull up my build script stuff. So let's go one level higher. So if I look at my workspace, I have two projects, the Matterhorn and the Switzerland project. The Matterhorn is the iOS project. So I'm gonna get a little build script going. So if I have build iOS.sh, there we go. So it's the same stuff. It's we go to the Switzerland folder. I run cargo clean to make sure it's really up to date. Cargo build for UniFFI, then build the .a files for iOS. Yeah, I tried to do some parallel compiling, although it still blocks. It doesn't really help optimize that much. Generate the UniFFI bindings, rename the file, don't forget this. Remove the XCFramework before you generate a new one, don't forget this. Generate XCFramework, and that should be it. So we can make it executable. There we go, and we have a whole thing. And this will, you know, do all the stuff and compile. And the problem with this workflow, actually, let's go over all the problems. First of all, it's not capitalized. I know, it's terrible. I don't like that we need two files. Like, why can't we just have one nice package, right? That's one of the problems. Another problem is you can only do this for one Rust project. So if you have another Rust module, you want to include this, it's going to crash, because what happens is this Swift file will be generated for the other one too, and it's going to be like, oh, this Rust buffer already exists, so it's going to clash. So it's not namespace. That's really the issue. And this is also what I noticed with online guides. They stop here and they don't tell you this. So again, it's the platform, multi-platform fun, right? It's not officially supported, so you're going to have these weird problems. Let's see. Yeah, the other thing is I have this script running. It's all great. but what happens is every time I have to like drag this file in, delete the old one, go to this one, drag that in, and I can script that too, but it's not the nicest solution. So what I recommend is we make a Swift package. Then this Xcode project will just depend on the package. Yeah, and if we just put files in this Swift package, it will just update, right? It's a local package. So, and it will be namespaced, capitalized. It solves all our problems. And I think it's also the nicest solution. So let's just do that. So it's still compiling, but whatever. Let's go to my notes. Yeah. So we have our files, right? We have the script, iOS project, Rust project. Let's make a new project. Let's call it Switzerland, because it's Swift in Switzerland. Gonna make this the Swift package. Now, unlike Cargo, we need to go in here. There we go. Let's see. Here we go. We're gonna initialize it. Make it also a library, because it is a library. We call it Switzerland, right? Because they're hilarious. There we go. So these are the files we have. Yeah, if I just look at the folder, I can just open package.swift. So this is like the cargo.toml file, basically. So what I'll do now is I'll overwrite this with my own stuff. I think this is missing. Yeah, there we go. And let me clean this. Okay, so I will rename the library Switzerland, so it will be import Switzerland. The reason is if you don't use, you can still, but you can, if you call it Switzerland, then the Xcode project can import both Switzerland and Switzerland. Should have picked a different name, maybe it's hard to pronounce. Because the Rust library is also exported again, so I was like, yeah, let me reduce it to one name, which is again Switzerland. But this project is called Switzerland. We'll add the Switzerland FFI XCFramework, which has this name that we had imported before. Also some source files like the Swift file. So what I can do is, and this is going to be part of the script, if I am in the root, I can make a directory if it doesn't exist, and makes this is the flag if it doesn't exist. Copy the framework file and copy the Swift file. Okay, so that's what I did. So here it is, that Swift file and the framework. Okay. Now the next thing is, let's go to Switzerland, our Swift package project. You know, I want to be like, oh, I want to build it. Okay, let's go build this project. Awesome. Doesn't work, right? We saw that error pop up at Xcode. So what happens here is we compiled the Rust libraries to two frameworks, two architectures, iOS and Simulator, but not Mac. I can do that though. We can do that, but it's a bit out of the scope. So what happens is it tries to run it on Mac. So it's going to throw all these cryptic errors about Rust buffer. But the real problem is there is just not a Mac architecture. There's also why I added a platform here. So what you can do though is you can say it must run on iOS. So I'm going to do that with this nifty command. And it will run on iOS platforms from the command line. Hey, it works. Okay, perfect. So we now verified the package works. Now we go to the Matterhorn iOS project. So we can delete these files, right? Because we're gonna depend on a proper Swift package. Okay, so let's do it. File, add package dependencies, add local, Switzerland. I think I detected it earlier, but okay, it's there. Import Switzerland. Let's see. Oh, make sure also it is here under frameworks, libraries, embedded content. That's also a step. If you don't have it, you should add it there. Let's see, anything else? And it should be Switzerland. There we go. Hey, it works. So I'm gonna run, yeah, simulate is slow. But the point is, it works. I can fast forward the video so you can see it works. Let's see if it works in the preview. It's all slow. Yeah, there you go. Platform words are allowed. Okay, perfect. So it works. Yeah, great, right? We have quite a lot now. We have a whole Rust library and a Swift package. And it's just linking to real projects. So pretty neat. So let's update our build script to include this Swift package stuff. I'm gonna get it out. Let me open the build script. And then we're gonna see a workflow. So we have build iOS, right? Let's open it. Let me update a new one. So it's the same as before, but what I'm adding here is it copies the files. So basically builds everything, Rust, copies it to the Swift package. And the cool thing is, let's say if I make an adjustment here, okay, and I run build iOS. Okay, I'm gonna fast forward this video because this will take a while. Okay, so our script did its course, right? It ran its course. So it automatically copied everything to the Swift package. What is nice about it is the code will automatically be updated. I think that's really cool, right? I just ran the script and in Xcode it's all working. So it completely created a tool chain, right? We have the Rust code, create the package, compile everything, generate the bindings, generate the XCFramework, put it in the Swift package, and Xcode sees the Swift package and it's like, okay, it's updated, I'm gonna show it here. So I think this is pretty awesome. I think this is kind of the guide I wish I had, so that's why I'm making it. Yeah, complete workflow. So yeah, I think, you know, this may feel like a lot of steps, right? But in the end, what we really did was make a Rust project, generate UniFFI bindings, made a Swift package, and use the Swift package in the Swift iOS project. So I think that's pretty feasible. I think, especially with this build script, and it can be more mature, more, you know, maybe even generalized to support more Rust modules and whatnot. I think it's very workable way of working or workflow. So yeah, I hope you enjoyed it. I hope you saw how relatively easy it is to get it in there. I hope you understood all the steps, or at least know what's going on and get an idea of what it takes. And the next steps will be to write an actual useful Rust library. Maybe I guess one thing I could show as well before we end up is if you have like little types. I have like a little Rust code to enhance the platform wars part. But I just wanted to show the code is that if you have like a struct, like in Rust, you would have a record, like a macro. And for enums, which again are the same in Swift, really, almost the same, is you have UniFFI enum definition. So you can expand on this code, you know, play around with it and see how it compiles to iOS. Yeah, so thank you for watching. So if you want to learn more, you can follow me on Substack, mobilesystemdesign.substack.com. And if you're interested, I also have a mobile system design book, which is not Rust specific, but more about architectures and how to be a better developer, even for senior developers. Then check out mobilesystemdesign.com/book. Thank you.